This polar plot is called a rose curve, and its equation is r of theta equals cosine 4 theta. So the 4 next to theta is what makes it a rose curve. And theta here runs from 0 to 2 pi. So we're going to start out, we're at theta equals 0, and then cosine of 4 times 0, that's 1. So we start out right here. So first thing, we started out at 1. We start heading towards 0. We cross, but now it's negative. And so the first bit we only actually made half of a petal. And here's the end of the petal. So every time you go between a 0 and a 0, you're going to make one more petal. And we'll see that, I think, for 8 petals total. So it's 4 times 2 from that 4. Let's go ahead and watch. So we've got about 4 petals now, but they're not symmetric, but you can kind of see if you rotated them, they're going to fill all the other spots. So now only about 2.5 petals left. And finally the last half petal. So this is a rose curve, more like a daisy curve in my opinion, but this is the shape it ends up making. And it goes through 0 to 2 pi in this case because the 4 is an even number. If it had been 3, as in the next example, then you actually only go 0 to pi, it ends up tracing itself out. So another rose curve, but this one is going to be qualitatively different, so r of theta equals cosine 3 theta. You trace out all the petals within just 0 to pi instead of 0 to 2 pi. Once you start going past pi, you're going to end up retracing the petals. Let's go ahead and watch that. So similar to the previous one, starts out making half a petal, gets to the 0, and then this next bit of the cosine of 3 theta will make another petal. And this one is already a little easier to see maybe the symmetry that it's going into thirds. Alright, and almost done with the third petal, so by the time we get to here, we're going to start retracing our steps. And so that's why its theta is 0 to pi instead of 0 to 2 pi. For pi to 2 pi now, it's just going to retrace what's already been done. And so to figure that out, first you can remember it. If this number is odd, then you go 0 to pi and it makes 3 petals in this case. If the number is even, then it will make 2 times that number. So the previous example was 4, so we had 8 petals, and that went 0 to 2 pi. You can end up proving that analytically as well. So if you use the periodicity of cosine, so if you add 2 pi in the argument, then it's the exact same function. And if you also replace theta with theta plus pi, that shifts it, and using those two facts, you can actually show that it's going to either completely rewrite over itself, or it's going to continue doing some new paths as it goes from either 0 to pi or 0 to 2 pi.